Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have these problems: longest unequal adjacent groups of subsequence one. Yeah. So this problem tagged as an easy, but yeah, like we will solve. We will basically try to make our own template to basically solve any similar kind of problems if we encountered in future. So yeah, first we will understand the problem statement, then on intuitions building part I will explain what actually the templates we are going to follow to this particular. Yeah, so they have given an string array words and a binary array groups, both of length n. A subsequence of words is alternating if for any two consecutive strings in the sequence their corresponding elements at the same indices in the groups are different. That is, there cannot be consecutive 0 or 1. So your task is to select the longest alternating subsequence from words that we have to build from the longest alternating subsequence from the words that we can build after satisfying these conditions, that the groups, the indices that we are selecting from the groups, that for every alternating indices they are different. Return the selected subsequence. If there are multiple answers, return any of them. So here basically take a note of these particular things. Return the selected subsequence. So they are basically asking for to return us the subsequence altogether. They are not asking us to return the length of it. So there are two kind of problems. So if in a particular problem they are asking for to return the long, so here it is longest unequal adjacent group subsequence. There is a very popular known algorithms, that is LCS, longest common subsequence, longest LIS, longest increasing subsequence of dynamic programming, that you must have to solve before of your interview. Any top product based company is bound to ask, like majorly they are asking to longest increasing subsequence, variant of longest increasing subsequence. So there are two basically variant of it. First one, so if I can go to our OneNote. So the first variant is, so the variant 1, what happens, I try to, so on variant 1 they are basically asking to length of it. So it can be either longest increasing subsequence or what they have given us, like longest unequal groups adjacent subsequence. Or the second variant is print it. So there are two variants. First one is like length, second one is print it. So first one is I have to say an easy for sure, and the second one is obviously a medium kind of problems, because they are basically looking to print it. So you have to store it when you are finding the length, so that you can print it also in the next subsequence job that you are performing to your algorithm. So that is kind, I personally feel it is kind of a medium compared to it. It's kind of a difficult compared to that first one, that is of easy ones, that is of length of it or size of it. Yeah, so on this particular problems they are basically asked for the print it. So print it, that means the medium difficulty or not an easy difficulty problems. Yes, so now you can see on the example test case. So I think the problem statement on overall is quite straightforward also. If we can iterate on the example test case, then also you guys are going to get a more strongest grip on that. So words they have given EAB, groups they have given 001. So problems they have already stated our words and groups are always bound to be on same length. So the answer they have returning EB. The reason is very simple, because they have selected this 0, and for this 0 can I select this 1? Can I select this 0? No. Then adjacent groups, adjacent indexes of the groups are identical, that we can't do. So we obviously have to select 01. So first 0 this and this one is a valid. So we can print EB. This is also invalid. The middle 0 and the last one, yes, it is also valid. Then on that case AB is also valid, but they have clearly stated if there are multiple answers, return any of them. So we can return either EB or AB is also fine. They have written EB. So now you can just focus on the explanations part. A subsequence that can be considered EB because group 0 and group 2 are not equal. 0, this 0 and this one which we already highlighted, these are unequal. Another subsequence can be selected AB, that we just discussed, group 1 and group 2, that are also not equal. So it can be demonstrated that the length of the longest subsequence of indices that satisfies the conditions is 2 only. Yes, so that's the reason you can either print EB, you can either return EB or AB. On this particular examples you can see they have selected ABC, this one, and you can see groups of 0 not equals to groups of 1, groups of 1 not equals to groups of 2. So they have selected this 1 0 unequal, adjacent, unequal. This 0 can go to any of this A, B, C. This can go to this one, or this can go to this one also. So A, B, C is also valid. A, B, D is also going to be valid, right? Another subsequence can be A, B, D that we just saw here. So because group 0 and group 1 and group 1 and group 3, then that is also going to be a valid pairs, adjacent or unequal, adjacent or unequal. It can be shown the length of the longest subsequence of indices that satisfies the conditions is 3. So that's the reason you can either return ABC or you can return ABD. Any of them is. So I think the problem here on the very first go is very straightforward, and the constraint is very small. So that's the reason they have act as an easy difficulty. So words length and groups length can grow as big as 100, and your words of I dot length can big as 10, right? So your words of I, this can grow as big as like 10, and what they have given, groups of I is either 0 or 1. Groups of I is either 0 or 1. Yes. So now words consists of distinct strings. So these are all our distinct strings, and words of I consist of lowercase English letters that are bound to happen. So by seeing this, by seeing the entire things, so are you guys are able to see a choice things? Now if we can go to our OneNote quickly. So what actually the things that we have to look into? So we have two things. One is words. They have given a list, and they have given a groups list. So there are two lists. Now out of them, which actually the point of constraint to us? Can I say it's group? Yes, it's group, which actually we have the constraint. So groups of, we are selecting whatever the indexes in the groups. So groups of I should not be equals to groups of J, whatever the next indexes of the subsequence that we have selected. So both are bound to be unequal. So we definitely have to focus on our groups on. We definitely have to focus on our groups only on this particular topic. So what we can do, so if I can draw a groups array, so it can be considered 0, 1, 1, 0, 1, something like this. So now on DP, we have choices. So definitely a DP solutions is going to be fit for this particular solution. So LIS that we have just explained. So if they are asking to print it, then we have to consider a parent array. Parent array to basically store which of the indexes is connected to whom. Like this index has reached from which particular upstream indexes. This particular index has reached from which particular indexes. This particular DP is going to be updated to which particular prior calculated DP. So now, so you definitely need, so if they have asked to print something, so you definitely need a tabular version. So we definitely need a tabular solutions here. We can't do recursive. We definitely need a tabular. When they have asked to print it. So now for DP, we know we just have to formulate our entire things. We have to just formulate our entire things to a particular index. If we can do so, then I think our job would be done. So let's pick an arbitrary index this. So this is, let's suppose, our particular index. So for that particular index, we definitely have a DP array. So let's suppose that is our DP of I. So this particular index can pair to whom? Any of its left, any of its which left. So not all left. Some conditions. For which if I am standing at any particular groups of I, it can pair to any j. J can be in range of 0 to I minus 1. Any of its left, where groups of I, tell me these things. Groups of j not equals of groups of I and groups of j. For them it can pair. Obviously it can pair. So on that case, tell me, what is the update then? My DP of I should be, so it can pair. Let's suppose I have some zeros here also. So it can pair to these zeros, it can pair to these zeros. Now which zero I have to consider? With this one. So out of them, which is taking more length. So let's suppose this is already have some values where this subsequence length is 5, but this 0 has some length for which the subsequence length till this is 4, but for this till this is 5. So we definitely have to pair with this so that our size becomes 6, because 5 plus 1, now my size is going to be 6. So I would be very, very greedy here. I will check for all the j's, and I am going to checking which particular j's are satisfying these conditions. That the bound have to do. And for all the j's which are satisfying, sorry, so for all the j's which are satisfying these conditions, what extra things we have to put? So can I say that particular current size? So if I can write it, what is the current feasible size it can give me to? It is nothing but whatever the dp of j, because till j what is the largest size. So how I can find this? 5 and 4. I will query to their dp of j's. I am going to query to their dp of j's. That is going to give me whatever the largest subsequence we are able to build. Till this index is going to went out by this. Till this is going to went out by this. So I will be query to that dp. If groups are satisfying, I am asking to the dp of j's. What is the values you already have hold? So my new size is going to nothing that dp of j, whatever the size they have hold, is plus equals to 1, because I am already considering one more element. And I am basically checking. I am now I can check if my dp of I, that the current size that the current index has found some of the j's for which whatever the past it's calculated, whatever the past it has calculated, its size is more. If it's paired to that particular j, its size becomes more. It can large more. So tell me, then I should obviously update my dp of I to the size. And for the current index, because we have to print the subsequence also. So we always have to build a parent array. So parent array, now I can give you a high level gist how actually the parents array is giving to help us. So initially I have initialized all the parents with 0, 1, 2, 3 to everyone is parents of himself. So on this example test case, if it is going to this particular index, if I can write index 0, 1, 2, 3. So this third index is going to pair with these elements because it has size 5. So initially my parent of 3. Initially everyone its own parent. Initially everyone is its own parent, right? So here I have wrote, right? Parents of everyone is same. But when this 3 can pair with this 0, I am going to change its parent to this particular index. I am going to update, hey 3, your parent is 0. So parent array is going to store at its third index. So if I can draw the parent array, 0's parent is 0, 1, 2. Initially third parent is himself. But if I am able to, by all the conditions, groups are unequal, then size is also going to be increased. If I am going to pair with him, so I am going to pair with him, then I am marking my parent is nothing but 0. Yes, I can obviously do this. So how it is going to be help? So when I have my maximum size, my maximum size, let's suppose my maximum size is coming to be 6 on that case, right? 6 on that case, then I can write it a simple while loop to print it. I will just going to write it to my max size, and I can just iterate to my parent array to print actually the answer. I will be coming on that how it is going to be help. But here I have just giving you the gist how we are going to update the parents array. So when we are going to jump on the parents array, so when we want to know who is the parents of 3, so it is point to 0. So we are at 0 index. So when we are asking to who is the parent of 0, 0 is stating I am itself my parent. So if we are encounter such things, then we are not going to move further, because then on that case we have already printed out our entire subsequence. So that is exactly how the parent array is going to help to solve this kind of problems, to print it. So here as we are updating our DP, so we obviously have to update our parent. So our parent of whom? Parent of I is whom? It's j. Parent of I, we are going to store a j. Yes, and after that we are obviously going to check if this particular size is beyond my max size. I will obviously store a max size, that is the longest subsequence that we can build to the entire array. If that is so, then we obviously have to update our max size. Our max size is going to be updated by size of also. And how we can basically print the parent array. How parent array is going to help us to print. So where our parent array got. So if like this way, let's suppose I have further more connections, x, y, z. So let's suppose this z is connected to this, and this one is connected to this, and this one we know is connected to this. So we have to traverse this, and this. So what we actually need, we need actually the last indexes of the largest subsequence that we have ended. So if I got the last index where our largest subsequence then we can iterate to our parents array, parent of last. Then if we do parent of last, we are going to hit here. So the index is going to be parent of last. Then we are going to call it parent of index. then we are going to jump here, then we again call it parent of index, then we are jump here, like this way. So we definitely need the last index, so that we can start this jump. We can start this jump. So that's the reasons when we are updating our max size, we are also storing the last index of our largest subsequence is nothing but this I, because this I is giving us the largest subsequence, right? So now, like this way, we have built our entire DP things. We have built with our entire DP things. Now what is pending? Just to print it. So I know what is the size of our longest subsequence is nothing but the max size. So we have obviously going to iterate to our max size that many times, and I have initialized to my answer. To an empty list, and what we are going to append to it. I can directly append answer.append. What I can append to my answer? I can directly append what is the last index. What is the last index I have it? So I can add words of last index. I can add, so that I can get the words of last index I can add, and my last index on that case for next iterations is going to be switch. I have to go to the parents. So it's nothing but my parent of last index. So when we are making this call parent of last index, it is just going to go to the just before of that. And we have encountered, we have print one elements, we have considered one elements of the max size, we have considered one elements from our subsequence that we have to print. So our max size is going to be have to decrease. And finally, how we are appending to our answer? If you remember, we are appending to our answer from reverse. We are appending, right? We are iterating to the reverse, because we are iterating from last index to the very start, So one thing is obviously remaining. So don't return answer as it is. Return answer by doing a simple reverse. How we can doing reverse? Colon -1 in Python. That will reverse your answer for sure. So please take a note. We have to reverse this answer before returning. Don't return the answer as it is. Then you are obviously going to get around this. Return it in reverse order, because we are iterating to the parents array in the reverse order to build the answer, and finally reverse order and return. That's it. So now we can quickly go to the code iterations. So here you can see. So what I have started with, I have declared my n equals to len of words. I have declared my DP. I have declared my parent array. That we definitely. So now I have started to feed every values to it. So for I in range n, I have already stated that my parent is going to be initially every index is parent of himself. So I am putting parent of that particular index to be that particular index only, and DP I am going to store everyone's to be 1, because everyone's as an individual element is a valid. Valid element. And my last largest index I have start with, that we definitely need, right? To reverse, to go from last largest index, we are going to iterate from the parents array to jump on the parents array. So my last largest index I have initialized with 0. In the max size, we are going to get at least one max size. So I have initialized with 1 only. Now here I have done the exact same things. So where we have used this anything that is not needed, I guess. Yes, so I have started with for I in range n, if it's working fine. For I in range n, and for j in range it's working fine. Yes, so and j we are iterating from I -1 to till 0, that we already discussed. I is going to be go to forward, and j is going to be iterated backwards from I -1 to 0. Now if groups are unequal, then we have to consider it. Then my size is going to be that particular groups which is going to be unequal. What is the size? Who is going to provide us? DP of j is going to provide us, and including me, size is going to increase +1. And if this size is exceed my DP of I is already holding, then update DP of I of which size, and update your parent also. So current parent of I is then j. And if my size is also breaching, if the size is also breach out the max size, then my max size also need an update. And that is the largest index I have to consider, where I got the largest maximum size subsequence that we are trying to build. So I have updated my last largest index to I also. And now I have just to print it. Printing is very simple, as we are maintaining our parents array. We are perfectly updating. So answer equals to empty, while max size because we know that many elements is bound to be in our words length final output, final largest subsequence list. So we are iterating to our max size time. And we are iterating answer.appends words of last largest index that we exactly discussed to our one node. Answer.appends words of last largest indexes. Yes. And And then we are moving our last largest index to parent of largest indexes. Parent of last largest indexes. So that means this jump from last largest indexes, we are just moving to the, when we are calling its parent, we are going to backward. We are going to backward. Just from the very last largest index, we are going to backward. We are coming in the forward directions by doing a backward jump. From this. And my max size is also going to be decreased. And finally, we can reverse the answer and return it. So that's exactly the submissions that I have did here. But I know there is a like most optimal solutions top of it which can work in big of n, but I submitted with big of n square because there is a reasons, because this is my template which is going to be fit for any of printing kind of things where they are basically asked to print the things, print the subsequence. Then that is the template that we have to follow, or you have to write it on the tabular DP, and on tabular DP you have to update your parent array very sharply, very smartly. You have to update your parent array, and like this way you have to print it. This way you have to print every element from your parent array if it is correctly printed. So that's the reason I have submitted with that submissions. But I know that is not the most optimal solutions that can be solved in big of n. So because we have few more looseness, right? The groups is only contains 0 and 1, but let's suppose your groups contains any number, then also these solutions will work as it is. So that's the reason I have tried to submit it, the generic submissions which can be fit to any kind of solutions where they are looking for print, but you can try to your own to the big of n, that is the most optimal solutions. That is also like quite straightforward also. So if you are not able to understand how big of n also going to be fit here, so please try to do a comments on this particular video. I will create a separate video for that, but please try to set this particular template to your brain, because this template is going to help you a lot to solve longest in subsequence printing kind of things. Dynamic programming, where they have asked to print the subsequence, that is the template you have to follow to every time. So that's the reason I have submitted to this template with this template. So now we can quickly discuss the time complexity of this particular submission. So that time complexity, this is for sure doing big of n squared job. Yes, here we are doing big of n job. Here we are doing another big of n job. And here reverse is also going to be taking a big of n for sure. So how many big of n? 1, 2, 3 big of n. So standard big of 3n for sure, plus big of n squared, where we are basically creating our DP table. And on space complexity, tell me guys, what is the space complexity? DP is going to be take big of n, parent is going to be take big of n. That's it. We are not using any more, right? Are we using any more? Nope. All are variables. Answer we generally don't consider, because that is the return type, so you have to anyhow provide. So that is going to take a big of 2n for computations. But explicitly tell to your interviewer that if he or she is good to consider answer also, then the complexity is big of 3n. But generally we don't consider the space which we are using to return our answer. So that's all about not the most optimal solutions, I have to say, but definitely you have to know the templates. I definitely suggest to know this template. So that's the reason I have submitted and explained this particular submissions to this particular video. And if you guys are able to understand till this point, so please do subscribe to the channel. Please share the videos to your friends who are also preparing for top product-based company and preparing their DSS skills. And please turn on the notifications so that when we are going to live to our next video, we get the notification as soon as possible. So that's it guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye guys. Bye.